Okay guys, so our first equation is x plus 11 equals 34. Remember, my goal is always to get x by itself. So what exactly are we trying to get rid of first?
The 11.
We're trying to get rid of that plus 11. So what would I do to get rid of it?
Bring it down below 11 and then bring it below 34 on the other side.
Okay, so I brought it down. What operation am I going to do with it?
Minus.
Yes, we're going to subtract. So whenever we're doing the numbers portion of this, I want y'all to get in the habit of, instead of saying bring 11 down, I want us to get in the habit of saying subtract 11, because that's what we're doing. We want to be intentional with our words. So what happens with my 11s? They cancel out, absolutely. Now what do I do? Yeah, we're going to do 34 minus 11, and what is that going to give us? Yes, we get 23, and we know that we have the x and the equals left, so we're going to bring those down, and we got x equals 23. Did anybody get something different? Good deal. Awesome, guys. Okay, let's look at number 2. For number 2, we had 57 equals x minus 21. What are we doing here? Yeah. Guys, we have, so you guys said the same correct thing, just the opposite ends of it. So we are going to end up adding, but in this original equation, we are taking away. So we have 57 equals x minus 21. So in this equation, we have a number, and we're subtracting 21. So what do we do here to get that x by itself?
Add 21.
Yes, thank you. We are going to add 21. And whatever I do to one side, I've got to do it to the other. Okay, what happens now? Yes, my 21s cancel out. Then what?
Add 21 to 57.
Absolutely. What is 57 plus 21? 78
Equals x.
equals x. Very, very good, guys. Anybody get something different?
I got 36.
Did you, it sounds like you might have subtracted.
I think I did.
You did.
I subtracted 7
Yeah, that's all right. That's all right. It's a common mistake. So let's give a little reminder of our inverse operations. Wow, I spelled that wrong, guys. Inverse, there's a V in there. Operations. I'm just going to do that for now. So our operations are those add, subtract, multiply, divide. Whenever we have a subtraction problem like this, or a negative number, how do we cancel that out? What's the opposite of negative or subtract? Add. Absolutely. So if we want to get rid of that minus 21, we've got to do plus 21. I'm going to actually zoom out and just push my camera closer. I think it's messing up the quality. Okay. Focus. That's better. Okay, so we always do the opposite to solve for x. And then just looking ahead, if I had multiplication, what would the opposite? Yes, I just heard it, Lewis. The opposite is dividing, division. Perfect. Okay, guys. Do we feel good about number 2? Okay about it? Okay, good. Let's move on to number 3 now. Number 3 got a little bit trickier. We had 56 equals 7 times x. What do I need to do here? Yeah, so anytime that I have a number being multiplied by x, to get it unattached from x, we need to do the opposite of what's happening here. The opposite of multiplication is division. So to get rid of 7 times x, we're going to divide by 7. And whatever I do to this side, I gotta do to the other. Okay. Is everybody following me so far?
Yeah.
All right. So what's going to happen to 7x divided by 7? My 7's are going to cancel out. All I've got left here is x. What is going to happen with 56 divided by 7?
Get 8.
You get 8. Very good. So I'm going to write 8 right below, and then, yep, equals x. Perfect. Wonderful. Any questions about number 3 before we move on?
I think I divided.
You think you divided?
125.
What'd you do?
I got 125.
Ooh. So did you multiply?
I believe so.
Let's see. I'll do 56 times 7. Did you get 392?
I got 125.
125. I wonder where you got that. Huh. Do you, ooh, is it on your calculator still? Do you know what you typed in maybe? Now I'm curious.
Gonna eat at you the rest of the day.
I don't know. What did you write on your paper?
I did it just like that.
Yeah, maybe,
Put x equals 125.
that is so interesting. It must have just gotten typed in wrong. I don't know what could have happened to make you get that answer. I'm really not sure. I don't know. I really don't know. Maybe, yeah, no matter what I do, I'm not coming up with 125. I don't know. Well, if you figure it out, let me know. But does number 3 make sense the way that we did it here?
Yeah.
Okay.
When you divided, right?
Yes.
Okay.
We just divided. Just divided. And for future reference, let's say you did write down the correct thing, but you got the incorrect answer. To make sure that you did do it right or that you got the correct number, we can always then go back and plug our x into the original equation. So if I found out that x equals 8, whenever I do 7 times 8, I should get 56. So let's try that. 7 times 8, I got 56. So whenever you do it again next time, let's say you get down 125, you wrote it all correctly, and there's nothing that would make you think it was wrong. It's always good to just go back and check. So I could do 7 times 125, and then I would see right there, yeah, that's probably not the right answer. But, all right, guys.
Since we know worked on times.
Yeah.
Divided.
Exactly. We're doing those inverse operations. Okay, let's do number 4 now. All right, for number 4, we had x divided by 5 equals 12. Now, I think on the screen, yours might have been written as x divided by 5 equals 12. Okay, gotcha. So either one of these could be what you see, but I want you guys to make sure that you are comfortable with this version as well. When we have an x over a number, this means that we are doing division. This is division, guys. So let's work it out on this one first, and we'll do that one next. Make sure we get the same answer, which we should. Okay, so I have x divided by 5 equals 12. What do I need to do here?
8 times 5.
Yeah, I need to multiply by 5 to get rid of that divided by 5. Yes, perfect. What's going to happen now? My 5s are going to cancel. So I can bring my x down, bring my equals down, and then what is 12 times 5? 60. Very good, guys. Very, very good.
And I did do that. I did 60 divided by 5 just to see if you
Perfect. That's good. That's good. Awesome, guys. And then as you can see here, this is the same thing. If I did times 5 to both sides, that would cancel. I'd bring down my x, my equals, and 12 times 5 is 60. Same thing. Same exact thing. Okay, guys. So, I'll give you a second to write that down if you still need to. And we are going to be moving on to a bit of a new topic today. It's the same stuff that we're doing here, but we're going to add an extra step. All right? Can I go to the next page? Okay. I'm going to rip this out real quick. And I'm going to write a little note of our topics today. So, today's topics. First of all, we are going to do a little bit of review on one-step equations, which, guys, one-step equations, that's exactly what we've been doing. And then today, we are also going to introduce two-step equations. So this is just for your information, in case you're curious about kind of the layout of what we're going to do today. So I'm going to start a little section here. One-step equations. And like I said before, those one-step equations are just exactly what we did just now and what we did yesterday. So for example, if I had x plus 48 is equal to 83, what would I be doing here?
Minus
48. Absolutely. We're going to take 48 away. We're going to subtract 48 from both sides. My 48s cancel.
them out.
And then we have x equals, what's that? 83 minus 48. 35. Perfect. So, I'm going to point this out a little bit here for you guys. This just took one step. The step we took here was subtracting 48. That's all we did. We only had to subtract a number and then boom, we got our answer. So let's talk about what's going to happen whenever we have more than one operation in an equation. Right here, there's just one, addition, and then we subtract to get rid of it. But what if I had an equation like this? What if I had 2x plus 7 equals 17? So I'm going to label this two-step equations.
So do we divide the 2 times 2 and just divide 2 into 2 and then add and subtract 7 or something?
So are you thinking like the order of operations? Like how we do multiplication
Kinda.
first?
Yeah.
I think that's a wonderful idea, but I got to teach you something today. Something different.
Okay.
Normally, when we are just doing a math problem where you're not solving for an x or anything, you would go in that order. You would do multiplication and then the addition.
Yeah.
However, I want you guys to think about how whenever we are solving for x, such as in the first one, even though it says we're doing x plus 48, to get our answer, we actually did the opposite thing. We did minus 48. So when we have more than one operation in an equation, we've got multiplication and addition. When we're solving, we do everything backwards. We always do what we call the inverse, those inverse operations. So normally our order of operations would look like P, E, M, and D for multiplication and division, and then A, S for addition and subtraction. But since we're solving an equation, we always do the opposite thing. So we're actually going to start with addition and subtraction, then multiplication and division, then the rest, which we don't have those right now. We're going to do the total opposite this time.
Well, we're gonna minus 7.
That's right. We're going to subtract 7. We're taking steps backwards to find our answer. So we'll do that to both sides. Now my 7's cancel. I get 17 minus 7. What is that? 10. Perfect. Then I'm going to drop down what I have left. I still have an equal sign, and I have 2x. So this was our first step.
So now we have to divide.
Yeah, it's like once you do this first step, I want you to think of this as a whole brand new equation. Now I have 2 times x equals 10. And Lewis, you said it yourself. Since we're multiplying here.
If we divide 2 by 2, then we gotta divide 10 by 2.
That's right. We're going to divide this side by 2 and the other side by 2.
And that's crazy.
I know. So my 2's cancel. I'll bring down my x and my equal, and 10 divided by 2, Diana said it, it's 5.
Wow.
Pretty crazy.
Yeah, it is.
So this here in blue was our second step. It's not so scary once you get the hang of it.
No, that's neat.
I think it's kind of satisfying, actually.
I think it's neat. It's cool.
Well, good. I'm glad you think so. Okay, so now that we know what a two-step equation is, let's do a couple of examples together. I'm gonna scooch that away so y'all can still see when I scoop my paper up. And let's try something really similar. How about 3x plus 6 equals 27. So remember, we're going to be doing everything inverse, everything opposite. So we have multiplication, 3 times x, and we have addition, plus 6. What is the first thing we need to do according to our inverse order of operations? Yes, we need to get rid of that plus 6. So in order to do that, we're going to do minus 6. We're going to subtract. Got to do it to both sides. All right. Then what do we do?
27 minus, those 6 cancel out.
Our 6's are going to cancel. And then what were you saying?
27 minus 6.
Yes, 27 minus 6. What is that? 21 equals, then I still have 3x left. So I got to bring that down. Am I done? I'm sure not. I'm not done. Now I have a multiplication problem. 3 times x is 21. What do I do here? Divide by 3. Yes, exactly. Divide by 3 on both sides. And what happens here? Yes, your 3's are going to cancel. We'll bring down the remaining x. It's by itself now, guys. Then we have our equal. And yes, 21 divided by 3 is 7. You guys are awesome. Good. Does that make sense to everybody? Good, good. Let's do another one together. Let's do 55 equals 3x plus 43. Okay. What should I do here first?
Minus.
Yes, we are going to subtract what number? 3x?
43.
Oh, yes, 3x means 3 times x. So we want to do that subtraction first. What's that?
We did the group text, but we were afraid you would miss it.
Okay, I want you guys to try to solve that one on your own for a second, and I'll be right with you. What are you getting?
I know the answer. That's all I came in for, is to solve the math problem.
Gosh, I'm gonna take too long. Thank you. I appreciate you. Okay, guys. What did we get?
X equals 4.
X equals 4. Did anybody else get that?
I did.
You did? Good. Did somebody get anything different? Did we all get x equals 4? Oh, we're about to find out. Okay, let's see. Here, I'll start working it out too while you're finishing up, and let's see if that's the right answer. Okay, those 43's cancel. Your answers are looking right, guys. Divide by 3. What'd you get?
4.
Yes, guys, are you serious? Y'all all got the right answer. That's awesome. That is wonderful. So x equals 4. We subtracted 43 for our first step, and then we divided by 3 for our second step. Good job, guys. Okay, I am going to write a couple of problems out for you to do on your own. I'm going to set about a 5-minute timer. And then we'll come back together and make sure everybody feels good about all of them. Okay, so for number 1, I'm going to have you do 12 plus 2x equals 32. And guys, I'm going to warn you ahead of time. I made these problems for my first period pre-algebra class, and I made them up on the spot, and I accidentally made it to where 3 of them have the same answer. So don't freak out if you get the same answer 3 times in a row. If you do, you're right. I just wasn't being creative enough with my equations, I guess. So that's a good thing. All right, there are those 4 problems. I am going to go ahead and set a timer, and when it is up, we will go over the answers. Okay, let's go over these equations. Number 1, we have 12 plus 2x equals 32. What do you guys think we should do first?
Subtract.
We are going to subtract. What number are we subtracting?
12.
12. Good. Did anybody start by wanting to subtract 2x?
Yeah.
Yeah, I can understand why you would want to, because you see the plus right next to the 2x. But we have to remember that this is different than whenever we were combining like terms, or like when we were doing the polynomials. This time we actually are going to solve for x. Those other times we weren't, so we would add and subtract terms like this. This time we're going to separate them. So we're going to see this as 2 times x, and then we have an addition problem with plus 12. So we are going to subtract 12 first. Let's do that. Minus 12, both sides. Okay, what's going to happen next?
12 cancel out.
Absolutely, the 12s are going to cancel.
And that's gonna be
20, perfect. 32 minus 12 is 20. And then we got to bring down the 2x equals. Did anybody not get to this point?
I got it.
You did? Good! Yay! That makes me so happy. Okay, now we have a whole new problem. 2 times x equals 20. Yes?
I have a question.
Uh-huh.
How come we didn't use the, we didn't put the 12 underneath the 2? Instead of doing, I'm confused.
Oh, so why didn't we put the minus 12 right here?
Yeah.
Because we aren't touching this yet. We are just trying to get rid of one thing at a time. So we see here that there's 2 operations that we're trying to get rid of first. We have an addition problem where we add 12, and then we have a multiplication problem, 2 times x. So
I think it's the x that's throwing me off, because I'm just looking at it as 2x instead of 2 times.
okay, what if we did like 2n? Would that be more helpful?
Yeah, because then we would know that I know I'm multiplying, right?
Okay, well, how about that? We'll use a different letter next time. We won't use x. I used to think that it was kind of confusing too, and you know, I should have known before I started using x all the time. I think it's just habits, you know what I mean? But moving forward, we'll try some different letters. Everybody feel good with that idea? Okay, cool. So now we have 2 times x equals 20. What's our next step?
Cancel out.
Yeah, we want to cancel out this 2 so that x can get by itself. What am I going to do to get that? Yes, I have to divide by 2
On both sides.
on both sides. Very good. Okay, now what?
Cross that out.
Cross out the 2's, they cancel.
20 divided by 2.
Yes, 20 divided by 2 is 10, and we got to bring down our x equals, and that is our answer. X equals 10. You got it back there? Yes! Good, 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 good.
Yeah.
Now, if you didn't get x equals 10, do you understand now why it is x equals 10? Okay, good deal. Let's try number 2. Number 2, we have 57 equals 5 times x plus 7. What's our first step?
Subtract.
Absolutely. We're going to subtract which number? 7. Good. Minus 7, minus 7. 7's are going to what? Cancel. 57 minus 7 is 50 equals 5x. Now what? Divide. We're going to divide by 5 to get x on its own, and what I do to one side, I gotta do to the other. So now, I'm going to bring down my x, my equals, and what's 50 divided by 5? Whoopsie, it's 10. I am going to give you some, number 3 is going to look similar. I don't know why I'm giving you answers of 10 every time. Did anybody not get 10 for number 2? You got it. Good. Okay, can we go to number 3?
Yeah.
Anybody still need a second to write? I'm happy to wait. Wait a second. Okay, let's look at number 3. 3 times x plus 15 equals 45. What do I do here? Subtract what? 15 from both sides. Beautiful.
15 cancel out.
Yes, 15 cancels out.
45 minus 15 is 30.
Good. 45 minus 15 is 30. Then I got to bring down 3x equals. Now what?
Divide.
Yes. We have 3 times x left, so to get rid of the 3, we divide by 3, both sides. And what's our answer?
X equals 10.
Yeah, x equals 10 for a third time. We love 10, I guess. All right. Everybody get that for number 3? Good. Okay, let's try number 4. We have 127 equals 17 plus 5x. What do we do first? Yeah, we are going to subtract which number? 17. Good. Both sides. Then what? 17 cancels out.
127 minus 17, 110.
Yes, 127 minus 17 is 110. And I got to bring it all down. Okay, now what? Divide. We have 5 times x. To get rid of a multiplication, we do division. All right. 5s are gone.
X equals 22.
Good. 110 divided by 5 is going to give you 22. Awesome. Yes.
So what if you threw multiplication, and division up in there
I'm about to.
instead of plus?
I'm about to. Just you wait.
Does
gonna-
that work the same way?
It works exactly the same. Exactly the same. So Lewis is kind of predicting the future here. He asked, what if we do something different, like where instead of dividing to get your answer, you got to multiply? I'm going to show you. How about, I'll make a little line to show that we're doing something different. How about if we had x, oh, I'm sorry, I said I wasn't going to use x anymore. How about we have, what letter do we like? Anybody want to give me a letter?
Do A.
A? Is A good with everybody? Okay, let's do A. What if I had A divided by 5 plus 30 equals 60? So remember, first, I've got 2 different operations here that I need to undo. I have divided by 5 and I have plus 30. What do I need to do first?
Minus 30,
Yeah, why are we going to do that first?
because we're going backwards from the order of operations.
Yes, exactly. Whenever we are solving an equation for an unknown variable like A, we have to use the order of operations backwards, just like we do inverse operations to cancel numbers. So my 30s are going to cancel. Then I'm going to bring down my A divided by 5, my equals, and what is 60 minus 30? 30, good. Okay, is anybody confused in any way, shape, or form at all? Nobody is judging. I just want to make sure we feel good. Are we confused at all about what we just did here? Good, good. Okay, so now we have a whole new equation. We have A divided by 5 equals 30. What should we do here?
Divide by 5.
So we already have divide by 5
Times
here.
5.
Yeah, we got to do the opposite, guys. Always the opposite. So division, the opposite is multiplication. And I'm going to just like do parentheses because I know that's multiplication sometimes too. Okay, so we have divided by 5. What do I need to do to get rid of 5?
Times
Times 5. Very good. We got to do it to both sides. All
it.
right.
You get 150.
Ooh, big number. Okay, so my 5s are going to cancel. I'll bring down my A, my equals, and Lewis just told us it is 150.
You know what I put?
Huh.
X equals.
That's okay. That's okay. I know, we get so used to writing it. That is all right. Okay, guys, I'm going to give you a little bit of a tricky one here. What if we had, I'm me bring that down a little. What if we had, I'll start a new page. I don't want it to get too messy for y'all. Negative 2, oh, you can't even see it. There we go. Negative 2 plus a divided by 10 equals 8. Oh my goodness, come
I'll
on.
tell you in a second.
Okay, first I want to know, what's the first thing that we want to do here?
Subtract
Ooh, what am I going to subtract?
negative 2.
Yeah, okay, good. Now, I want to show you something because this is going to mess you up. I'm going to just tell you, this will mess you up. If I was going to do minus negative 2, okay, I just know whenever I try to do that math, I'm going to be so backwards and confused. That looks very confusing to
Yes.
me. So I want you guys to remember, if I'm adding a negative number, just like we talked about last couple of weeks, it's the same thing as subtraction. So if I have a negative 2 to get rid of it, I can add 2. Remember, those two negatives together make a positive. So I'm not going to do all that. I'm just going to say plus 2. Is anybody uncomfortable with that? You can be honest.
So we're changing the negative.
Yeah,
Okay.
yeah. So remember, all we're trying to do is get rid of that negative 2 and get it to 0. So if I am at negative 1, negative 2, in order to get from negative 2 to 0, I think it makes a lot more sense to say, let's add 2, than to say, let's subtract negative 2. You're doing the same thing. Subtracting a negative is the same thing as adding, but I think adding sounds a little easier. Even to me, when I see minus a negative, it makes me feel
Yeah.
very uncomfortable.
Yeah.
Because it just doesn't make a lot of sense. So if we have a negative number, we add to get rid of it. That's going to cancel it. So if I do plus 2 on this side, what do I do on the other side?
Good on the other.
Exactly. I'm going to just do the same thing to both sides. So my 2's are going to cancel. And I'm on this side, I'm left with a divided by 10 equals, and what's 8 plus 2? 10. Okay. Now I'm left with a whole new equation. A divided by 10 equals 10. What do I do now?
10 times 10.
Yes, we have a division problem here, so in order to reverse it or cancel out that 10, we need to multiply by 10. When we have division, we undo it with multiplication. So my 10's are going to what? Cancel. Good. I'm left with A equals, what's 10 times 10?
100.
100. Good. Good job, guys. Very good. All right. Let me see. I've got a couple more practice like that I want us to try together. Okay. How about, I'm going to move this up. Does anybody still need to write this? Okay. Awesome. What if I had 26 equals I'm going to start X, sorry. A divided by 3, you are the best, minus 4. Thank you so much. You're welcome. Do I owe money to somebody?
No.
Oh, thanks.
We will be adding first
Yes. We are going to add first. What number are we adding?
4.
Absolutely. We're going to add 4 to get rid of that minus 4. Okay. My 4's are going to do what? Cancel. 26 plus 4. 30 equals, we still have A divided by 3. Now what do I do?
3 times 3.
Absolutely. 3 times 3 to get rid of it. We got to do the same thing to the other side. All right, now what?
10 equals A.
Make sure we cancel these 3's first.
Yeah, I did.
And then, what'd you say?
Times 3.
Yeah, so did you divide by 3, Dayana?
Huh?
Did you divide by 3?
No? Oh, yes, I did.
Yeah.
I mean 30.
That's okay, that's okay. So we're doing 30 times 3. What is that going to give us? 90. 90 equals A. Now let's say we did accidentally mess up and I did 30 divided by 3, so I got 10 equals A. What I could do then is plug that back into my original equation. So I could put 10. So now I have 10 divided by 3 minus 4. And we could check, does that equal 26? So I would do 10. Oh, my calculator's off. Okay, 10 divided by 3. Okay, minus 4. And we would see pretty quickly that is not equal to 26. So then you could go back and check your work and all that fun stuff. So I definitely recommend checking your answer if you get something that feels a little off. Just want to make sure that it's making sense to us. Okay, guys, how do we feel about that? We feel okay? Anything that makes us uncomfortable right now? Maybe a little bit. We'll do one more together, and then I'm going to give you your exit ticket. That's all we're learning today, guys.
So we know that whatever the number, I mean the letter, whatever numbers underneath the letter, that's what we're timesing by.
Yes, exactly. Because if I have A divided by 3, if it helps and if it makes more sense to you, you could actually write this out as A divided by 3. So this would be the same thing as 26 equals A divided by 3 minus 4. And then I'll work this out real quick so you can kind of see. I did the plus 4, and I got 30 equals A divided by 3. Then I know, okay, division, I'm going to times, or I'm going to multiply. My 3's cancel. 90 equals A. Does that make sense?
Yeah.
Good. Good. Okay, any other questions, guys, before I give you that exit ticket? Okay, very good. Let me just pull that up for you. And I'm happy to wait a second. Does anybody else still need these notes? Are we still writing at all? Okay. Here is your exit ticket. Right here. And I'm going to stop the recording.